Mootopia, the happy cow's high-tech haven. Now let's talk butter. Good eat style. Butter doesn't just magically appear on your toast. Oh no, it starts with milk, and not just any milk. We're talking about milk from happy cows. Yes, happy cows. It sounds a bit whimsical, I know, but science, my friends, backs this up. A stressed cow produces stress hormones. Those can affect milk quality and even quantity. So farmers are getting smart. They are creating bovine paradises. Think comfortable bedding, plenty of space to roam, and a good diet. That's the baseline for quality. But here's where things get really interesting. Some dairy visionaries are taking cow comfort to a whole new level. Picture this. Cows wearing virtual reality glasses. I kid you not. These VR headsets show the cows images of lush green pastures, sunny skies, endless fields. It's like a spa day. But for their minds, the idea is to reduce stress and boredom, especially for cows that might be housed indoors during harsh weather. Less stress equals more relaxed cows. And relaxed cows, well, they tend to produce more milk and potentially better quality milk. It's a fascinating intersection of agriculture and high tech. The impact of this bovine zen state is quite significant. When a cow is calm, its body functions optimally. Milk letdown, which is the release of milk from the udder, is smoother and more complete. Some studies suggest that lower stress levels can lead to milk with a better fat composition. And fat, my friends, is the golden ticket when it comes to making butter. So these happy VR-gazing cows aren't just a quirky headline. They represent a serious approach to improving the very first step in our butter-making journey. It's all about starting with the best possible raw ingredient. So before that milk even leaves the farm, a lot of thought goes into the well-being of the animal. It's not just about quantity anymore. Quality is king. And quality begins with a happy, healthy, and surprisingly high-tech cow. From carefully managed diets to these futuristic VR experiences, farmers are pulling out all the stops. This commitment to animal welfare directly translates to the milk that will eventually become that delicious pat of butter on your morning muffin. It's a chain reaction of goodness starting right there in the barn. Good for the cow, good for the milk, good for your butter. All right, so our cows are happy, possibly even virtually frolicking in digital fields. Now, how do we get that precious milk from the cow to, well, the next step? This isn't your great-grandpappy's farm with a three-legged stool and a metal pail anymore, at least not on most modern dairy farms. We're talking automation, folks. Sophisticated, gentle, and efficient automated milking systems. These systems are designed with both the cow's comfort and milk hygiene in mind. It's a marvel of engineering, really. Many farms now use robotic milking systems. A cow decides when she's ready to be milked. She simply walks into a milking stall. No prodding, no stress. The robot then uses lasers and sensors to locate her teats. It cleans them with gentle brushes or a special solution. Then the milking cups are attached automatically. It's all very calm and orderly. The cow often gets a tasty feed ration while she's being milked. This encourages her to participate willingly. This voluntary milking system means cows are milked when they feel the urge, not just on a rigid human schedule. The milking process itself is carefully controlled. The machines mimic the natural suckling of a calf. This ensures efficient milk extraction without causing discomfort to the cow. As the milk flows, sensors monitor its rate. Once the flow slows down, indicating the udder is nearly empty, the cups detach automatically. This prevents over-milking, which can be harmful. The milk doesn't see the light of day, or rather the air of the barn. It travels through sanitized pipes directly from the cow to a cooling tank. This immediate cooling is crucial to prevent bacterial growth and maintain freshness. This automated approach offers several big advantages. First, hygiene. The closed system minimizes contamination risks. Second, consistency. Each cow is milked in the same gentle and effective way every time. Third, data. These systems collect a treasure trove of information on each cow. How much milk she gave, how often she was milked, even early indicators of potential health issues. This data helps farmers manage their herds more effectively. So this high-tech milking isn't just about saving labor, it's about better cow health and higher quality milk. And that, as we know, is essential for top-notch butter. So we've got our milk. It's been collected gently and efficiently. It's sitting in a chilled tank, waiting for its destiny. But hold your horses, or rather, your churns. Before that milk goes anywhere near a butter-making facility, it has to pass some serious tests. Think of it as milk's final exam. Or maybe its report card. We need to ensure it's safe, pure, and has the right stuff to become glorious butter. Quality control at this stage is absolutely non-negotiable. It's serious business. The first round of testing often happens right there on the farm. Farmers might check for things like somatic cell count, which can indicate udder health. They'll also look for any abnormalities in smell or appearance. But the really rigorous testing happens when the milk tanker arrives at the dairy processing plant. Before a single drop is unloaded, samples are taken from the tanker. These samples are whisked away to a lab. Technicians in white coats, armed with sophisticated equipment, get to work. They are the gatekeepers of milk quality. What are they looking for? A whole battery of things. First and foremost, safety. They test for any traces of antibiotics. If a cow was treated for an illness, her milk cannot be used until any drug residues are completely gone. Strict rules, folks. They also test for bacteria counts. While some bacteria are harmless or even beneficial later on, high levels of spoilage bacteria are a no-go. Water content is also checked. No one wants watered-down milk. That's just not cricket. These tests ensure the milk is wholesome and meets legal standards. Then there's the composition analysis. This is super important for butter making. They measure the percentage of milk fat or butter fat. This is the star player in our butter story. The higher the fat content, the more cream can be separated and thus more butter can be made. They also measure protein levels and other solids. All this information helps the dairy plant decide how best to use that particular batch of milk. Only milk that gets straight A's on its report card moves on to the next stage. No compromises. This ensures that the journey to butter starts with the purest, highest quality foundation. Our milk has passed its exams with flying colours. It's pure, it's safe, it's got the right stuff. Now, what's the next step on its journey to becoming butter? Well, butter, as we all know, is made from cream. And milk in its natural state is a mixture of cream and, well, the less fatty part. So we need to separate that luscious cream. How do we do that? If you left raw milk to sit, the cream would eventually rise to the top. That's gravity at work. But in a modern dairy, nobody got time for that. We use a much faster, much more efficient method, centrifugation. Imagine a super-powered spinning machine. That's essentially what a centrifugal separator is. The milk is fed into this machine, which spins at incredibly high speeds, thousands of revolutions per minute. This rapid spinning creates a powerful centrifugal force, much stronger than gravity. This force acts differently on the different components of the milk based on their density. Milk fat, which makes up the cream, is lighter than the watery part of the milk. Think oil and water. The oil cream wants to float. Inside the separator, there's a stack of conical discs. As the milk whirls through these discs, the heavier skimmed milk is flung to the outside of the spinning bowl. The lighter cream, with all that glorious butter fat, collects closer to the center. It's a beautiful, continuous process. Skimmed milk flows out through one pipe, and rich, concentrated cream flows out through another. The efficiency of these machines is remarkable. They can separate vast quantities of milk in a short amount of time, and they can be adjusted to produce cream with a specific fat content, usually between 35 to 45% for butter making. The skimmed milk isn't wasted, by the way. Oh no, it goes on to become, well, skimmed milk for drinking, or it's used to make other dairy products like cottage cheese or milk powder. But our hero, the cream, is now ready for its next transformation. This separation step is absolutely crucial. Without it, you wouldn't get that concentrated fat needed to make butter. So, thanks to the power of physics and some very clever engineering, we've isolated the cream, the very essence of what will become our delicious, spreadable butter. Next up, we treat this cream right. Section 5, Golden Transformation, Cream's Journey to Butter Grains. We've got our cream, rich, luscious and packed with butter fat, but it's not butter yet, not by a long shot. The next phase is all about transforming this liquid cream into tiny solid butter grains. This involves a couple of very important steps. First up, pasteurization. Just like the milk it came from, the cream needs to be pasteurized. This means heating it to a specific temperature for a specific time. This kills off any lingering spoilage microorganisms or harmful bacteria. It also deactivates certain enzymes that could cause off flavors in the finished butter. Safety and quality always paramount. After pasteurization, the cream is cooled, and then For many types of butter, especially cultured butter, comes a process called maturing or ripening. This is where things get really flavorful. Specific strains of lactic acid-producing bacteria cultures are added to the cream. These are the good guys. The cream is then held at a controlled temperature for 12 to 15 hours, sometimes longer. During this time, these bacteria get to work. They ferment the lactose, which is the milk sugar in the cream, producing lactic acid and other compounds like diacetyl. Diacetyl is the compound that gives many butters that characteristic tangy, buttery flavor and aroma. It's a slow, controlled flavor development. Once the cream has matured and developed the desired flavor profile, it's time for the main event, churning. The ripened, or sometimes fresh, unripened cream is pumped into a churn. In the old days, this was a wooden barrel turned by hand or a small motor. Today, it's usually a large stainless steel continuously operating machine, but the principle is the same. The cream is agitated vigorously. This agitation breaks down the membranes surrounding the fat globules in the cream. These membranes normally keep the fat globules separate in an oil-in-water emulsion. As churning continues, these now exposed fat globules begin to clump together. They collide and stick, forming larger and larger clusters. This is a magical moment, folks. The emulsion inverts. What was once fat dispersed in water or cream becomes water dispersed in fat or butter. Tiny grains of butterfat start to become visible, separating from the liquid. This liquid is buttermilk, the real traditional buttermilk, not the cultured stuff you usually buy in cartons today. These little golden butter grains are the first solid signs that we are well on our way to making butter. It's a beautiful golden transformation. Section 6, wash day for butter, squeaky clean grains and buttermilk's farewell. So our churn has worked its magic. We have beautiful, distinct butter grains floating in a sea of buttermilk. It's a critical stage, but we're not quite ready to call it butter. The next step is washing these grains. Now, why would you wash butter? Sounds a bit odd, doesn't it? But it's a very important step, especially for the keeping quality and flavor of the final product. The main goal of washing is to remove any remaining buttermilk that's clinging to or trapped within the butter grains. This is crucial stuff. Traditional buttermilk, the liquid left after churning, contains lactose, which is milk sugar and milk solids. If too much of this buttermilk remains in the butter, the lactose can be fermented by bacteria. This can lead to sour or off flavors developing in the butter over time. It can also affect the texture. So washing helps to produce a cleaner tasting butter with a longer shelf life. In the old days, and still in some artisanal production, chilled water would be added to the churn after the buttermilk was drained. The butter grains would then be gently worked or agitated in this wash water. The wash water would then be drained, and the process might be repeated several times until the water ran clear. This indicated that most of the buttermilk residues had been removed. Modern large-scale butter making often uses continuous churns that incorporate a washing stage. As the butter grains form and move through the churn, they are sprayed with or passed through chilled water. This is more efficient and controlled than batch washing. The temperature of the wash water is also important. It needs to be cold to help firm up the butter grains and prevent them from becoming too soft or greasy. However, there's a bit of a debate in the butter world about washing. Some argue that for cultured butters, leaving a little bit of that flavorful buttermilk behind can enhance the taste. Unwashed butter, sometimes called European style, even if made elsewhere, might have a more complex, tangy flavor profile, but potentially a shorter shelf life if not handled properly. So the decision to wash and how thoroughly can depend on the type of butter being made and the desired characteristics. But for most commercially produced butter aimed at a long, stable shelf life, washing is a standard and vital procedure. It's all about purity and stability. Section 7. The salt shake and final churn, building butter's perfect body. Our butter grains are now squeaky clean, rinsed of most of their buttermilk. They are small, distinct particles. The next step is to transform these grains into the smooth, cohesive mass we know as butter. And for many of us, this is also where salt comes into the picture. Not all butter is salted, of course. Unsalted butter, often preferred by bakers, allows for precise control over seasoning in recipes, but salted butter is a popular choice for table use, adding its own savory kick. If salt is to be added, this is the stage. The amount of salt can vary, typically ranging from 1% to 2% by weight. Finely ground salt is distributed evenly over the butter grains. This even distribution is key to avoid pockets of saltiness. The salt does more than just add flavor, it also acts as a mild preservative, further enhancing the butter's shelf life by inhibiting microbial growth. So whether you're team salted or unsalted, this is a defining moment for the butter's final character. The salt begins to dissolve into the tiny droplets of moisture still present in the butter grains. Now, whether salted or not, the butter grains need to be worked. This is essentially a kneading process. In traditional methods, this might have been done by hand with wooden paddles, pressing and folding the butter. In modern dairies, the churn itself, or a separate machine called a butter worker, handles this task. The working process serves several critical functions. Firstly, it expels more of the remaining buttermilk and excess water. The goal is to achieve a specific moisture content, usually around 16 to 18% for most butters. This is carefully controlled. Secondly, working the butter compacts the grains, knitting them together into a dense, continuous mass. It distributes the remaining moisture in very fine droplets throughout the fat. This is crucial for the texture and spreadability of the butter. Proper working develops a waxy, plastic consistency. Underworked butter can be leaky and crumbly, while overworked butter can become greasy or sticky. So, it's a delicate balance. The butter is worked until it achieves that perfect, smooth, uniform texture and the desired moisture content. It's the final sculpting of our golden product before it heads off to be shaped. Section 8. A pat of history, butter's rich past, margarine's rise, and pretty packaging. Butter. It's been around for a very, very long time. We're talking millennia. Archaeological evidence suggests butter making dates back as far as 9000 BC. Ancient civilizations from the Sumerians to the Vikings all cherish this golden fat. It was a valuable food source, rich in calories and nutrients. It was also used in religious ceremonies and even as a form of medicine or cosmetic. Imagine ancient Romans using butter as a salve for burns. Its value was immense, sometimes even used as a form of currency. That's some serious dairy dough. For centuries, butter was made on a small scale, on farms or in homes. The methods were simple. Milk left to stand for cream to rise, then churned by hand in wooden churns. It was a laborious process. The quality could vary greatly depending on the season, the cow's diet, and the skill of the butter maker. Then came the 19th century and the Industrial Revolution. The invention of the centrifugal cream separator in 1878 by Gustave de Laval was a game-changer. It allowed for large-scale, efficient cream separation, paving the way for commercial butter factories. This industrialized the process, making butter more widely available. Now, no story about butter is complete without mentioning its one-time rival margarine. Margarine was invented in 1869 by Hippolyte Maurice in France. Napoleon III offered a prize for a butter substitute for the armed forces and the lower classes. Margarine, originally made from beef tallow, was cheaper. For a long time, the dairy industry fought hard against margarine, with butter wars leading to regulations like requiring margarine to be dyed pink so it wouldn't be mistaken for butter. Times have changed, and both now coexist, though true butter lovers know there's no real substitute for the real deal. Finally, after all that history and processing, our butter is ready to be shaped and packed. Butter can be formed into blocks, sticks, tubs, or even decorative shapes using molds. Extrusion is common for sticks, where butter is pushed through a die and cut to size. It's then wrapped. The packaging is important. It protects the butter from light and air, which can cause oxidation and off flavors. It also prevents the butter from absorbing odors from other foods in your fridge. From parchment paper to foil to plastic tubs, the packaging ensures that the butter reaches you in perfect condition, ready to be enjoyed. Section 9, Beyond Butter, the golden glory of ghee and its culinary charms. Our journey with milk and cream has led us to beautiful, delicious butter. But wait, there's more. We can take butter one step further to create another culinary treasure, ghee. Ghee is essentially clarified butter that has been cooked a bit longer to remove all the water and toast the milk solids. It's highly prized in Indian, Middle Eastern and Southeast Asian cuisines, and for very good reasons. It has a higher smoke point than butter, a nuttier flavor, and a much longer shelf life, even without refrigeration. It's liquid gold. Making ghee starts with unsalted butter. The butter is gently melted in a pot over low heat. As it heats, the water content in the butter will begin to simmer and evaporate. You'll see foam forming on the surface. These are the milk solids separating out. This foam is skimmed off. The butter will continue to cook, and the milk solids will sink to the bottom of the pan. The key is to cook it slowly until all the water has evaporated, and the milk solids at the bottom turn a lovely golden brown. This browning imparts a characteristic nutty, caramelized flavor to the ghee. Once the milk solids are nicely browned and the bubbling has mostly stopped, indicating the water is gone, the ghee is carefully strained. It's poured through a fine mesh sieve lined with cheesecloth to remove all the browned milk solids and any remaining impurities. What's left is pure, clear, golden butterfat. This is ghee. As it cools, it will solidify to a creamy, sometimes slightly grainy texture depending on the ambient temperature. The color can range from light yellow to a rich golden hue. It's truly a beautiful product. Ghee is incredibly versatile in the kitchen. Its high smoke point, around 485 degrees Fahrenheit or 250 degrees Celsius, makes it excellent for frying, sautéing and searing without burning. It adds a rich, nutty flavor to dishes that regular butter can't quite match. It's a staple in curries used for tempering spices, drizzled over flatbreads and incorporated into sweets. Beyond its culinary uses, ghee also holds a significant place in Ayurvedic traditions, where it's valued for its health benefits. So, from happy cows to creamy butter, and then to glorious ghee, it's a remarkable transformation of milk's goodness. Now that's what I call good eats.